Deep learning feels like it's absolutely everywhere these days, right? From your phone's camera to cutting-edge medical labs. But here's the crazy thing. The basic ideas behind it, they've been around for decades. So why now? Why is this revolution happening right this second? Well, let's dive in and pull back the curtain on the three key forces that finally unlocked its true power.
So to really get what happened, we first have to understand the core problem that AI has been trying to crack for years and years.
And this slide just nails the fundamental difference. You and I, we can glance at a picture and instantly know, hey, that's a cat in a cowboy hat. It's just intuitive. We're wired for it. A computer, on the other hand, is a rock star at things that make our brains hurt, like churning through bajillions of calculations. So the whole goal of deep learning is to make the computer a little more like us, to get it to learn intuitively, without needing a rule book for every single thing it might see.
Which brings us right back to the big mystery. I mean, if the concept of neural networks isn't some brand new thing, what changed? What was the secret sauce? What was the spark that turned this kind of old idea into one of the most powerful technologies of our lifetime? Let's find out.
Okay, the first piece of the puzzle, and honestly, this one is a giant, is something we're all swimming in and creating more of every single second. Data. Just an unimaginable amount of it.
So here's the key takeaway. One of the most surefire ways to make an AI model perform better is just to go bigger. A bigger network, and even more importantly, way more data to learn from.
And boom, this graph basically tells the whole story. Seriously, this might be the most important visual for understanding this entire revolution. Down here on the bottom, you've got the amount of labeled data you're feeding the machine. And going up the side, that's performance, how well it's doing its job. And as you can see, not all algorithms are created equal when you start feeding them tons of data. Just look at that red line. That represents the old school learning algorithms. Yeah, their performance gets better with more data for a little while. But then they just hit a wall. They plateau. They simply don't know what to do with these massive web-scale data sets we have today.
But now, look at that blue line at the top. Whoa, that's a large neural network. It is a completely different story. These things are data-hungry monsters. The more you feed them, the smarter they get. There's no ceiling in sight. They absolutely thrive on the kind of scale our digital world provides.
So where's all this data coming from? Well, just look in the mirror. It's us. Every photo we post, every Google search, every tap on an app, it all adds to this gigantic digital ocean of information. And that ocean? That's the fuel for the deep learning engine. Okay, so we've got the fuel, a whole ocean of it. But fuel isn't much good if you don't have an engine powerful enough to burn it. And that brings us to pillar number 2, computation.
This quote from our source material just hits the nail on the head. Progress in this field isn't just about the final model, it's about how fast you can experiment. I mean, think about it. If you can test out a new idea in 10 minutes instead of waiting a whole month, your ability to innovate just goes through the roof.
And that's exactly the gift that modern hardware has given us. Thanks to these super powerful GPUs and cloud computing platforms, researchers can now whip through this idea, code, experiment cycle at a blinding speed. Faster hardware means faster iteration, and that leads directly to breakthroughs.
All right, so we've got massive data and super fast computers. That's it, right? Case closed? Well, not quite. There was one more crucial piece of the puzzle. And this one wasn't about hardware, it was about the code itself. Let's talk about the third pillar, smarter algorithms.
Sometimes the biggest breakthroughs come from the most unexpected places. One of the key innovations was changing a tiny little piece of the math inside the neural network called the activation function. Turns out, just switching from an older function called sigmoid to a newer, much simpler one called ReLU had a massive impact on how fast these networks could learn. So let's break that down real quick. Think of the old sigmoid function as a gentle, curvy hill. When you get to the flat parts at the top or bottom, your learning just slows to a crawl. The model gets stuck. But the ReLU function? It's more like a simple, steep ramp for all positive numbers. The learning signal stays strong, and the whole training process just goes zoom, much faster.
So you see, it really is about having a smarter recipe, not just throwing more ingredients into the bowl. These clever little algorithmic tweaks act as a huge efficiency multiplier. They make all that data and all that computing power go so much further.
So what happens when you finally put all three of these pillars together? You get more than just progress, you get a full-blown revolution. Let's look at the payoff.
So here it is, the three-part recipe for revolution. First, you start with a massive ocean of data. Second, you pour in incredibly powerful computation to process it all. And third, you stir in smarter, more efficient algorithms to speed everything up. It was the combination of all three of these things at once that created the perfect storm for AI.
And this isn't some abstract theory. This is the recipe behind the tech you use every single day. It's what lets your phone recognize faces and photos. It's how your smart speaker understands what you're saying. It's even helping doctors spot diseases earlier and more accurately than ever before.
And you know, maybe the most exciting part of all of this? The revolution is nowhere near finished. In fact, all three of these forces, data, computation, and algorithms, are still accelerating. We're getting more data, faster computers, and even smarter code every single day. What we've seen so far might really just be the opening act.
Which leaves us with a pretty mind-blowing question to chew on. As these three pillars continue to grow and grow stronger, exponentially, what's next? What incredible new things are waiting just around the corner, waiting to be unlocked?